Hello everyone. Today we are going to study DC analysis of a common source amplifier circuit. Through DC analysis, we are going to find out transconductance, drain current, and VGS. Let's start. This is the common source amplifier circuit where source terminal is connected to ground through RS, gate is connected to the input and drain is connected to output. So we are giving input across gate terminal, taking output from the drain terminal where source is common to input and output. So we say this is a common source amplifier circuit where source terminal is common to input and output. VDD is the DC voltage source which is used to bias this circuit. R1, R2, RD, RS resistors are used to bias the transistor. R1, R2 is dividing the potential applied DC potential VDD, and C1, C2 are two coupling capacitors. CS is the bypass capacitor. Where VDD is now dividing across R1 or R2. Gate is separated by dielectric from source and drain. So across the gate terminal, the potential we can find out from this formula, and using this circuit where VDD is connected and this R1 and R2 resistors are connected. From this terminal we can find out the potential across the R2. So across R2 the potential drop, if it is VTH, then VTH equals to R2 by R1 plus R2 into VDD. Now to study the DC analysis, let's start find out the impedance of these coupling capacitors and bypass capacitor. Capacitor impedance Z equals to 1 by omega C, equivalent to 1 by 2 pi fc. Omega is equals to 2 pi fc. For DC, frequency is 0, so impedance is infinite. As the impedance of these capacitors are infinite, so we can open it and we can make a simplified circuit like this, where all the coupling capacitor and bypass capacitors are removed. Now this circuit we can simplify using Thevenin's theorem. Using Thevenin's theorem, we can find out Thevenin's equivalent voltage VTH, that's equals to R2 by R1 plus R2 into VDD, and we can find out the Thevenin's equivalent resistance. To find out the Thevenin's equivalent resistance, all the independent voltage sources will be shorted to ground. So here VDD will be shorted to ground. If VDD is shorted to ground, then R1, R2 will become parallel to each other. So the equivalent resistance of R1, R2 will be RTH equals to R1, R2 by R1 plus R2. So after finding out the Thevenin's voltage and Thevenin's resistance, we can simplify this circuit and make this circuit in a equivalent circuit of that, where VTH is the Thevenin's equivalent potential is applied across the gate terminal, where in between VTH and gate there is a Thevenin's equivalent resistance RTH. Now, using DC analysis, we are going to now find out transconductance, also VGS and ID. Now, first, how to find out transconductance? To find out transconductance, here we are considering three cases. First case 1, where the threshold voltage of the MOSFET is given, mu mobility is given, oxide capacitance is given, W by L ratio is given, and VGS is given. Then we can find out the transconductance easily. So we can find out transconductance using this formula, where transconductance Gm equals to mu Cox W by L into VGS minus VT. Now in the second case, if the VGS is not given, other parameters values like threshold voltage, mobility, Cox, W by L and ID all are given, then first let's find out the potential difference between gate and source. Now gate is separated by dielectric, so across gate there is no current passing through, so gate current IC will become 0. So the whole Thevenin's equivalent potential VTH will come across the gate terminal. So VG will become Vg equals to Vth, and we have already find out the Thevenin's equivalent potential Vth equals to R2 by R1 plus R2 into VDD. So VGS equals to VTH. Now VGS equals to Vg minus Vs. We have find out Vg equals to Vth, and let's find out Vs. Now to find out Vs, we have to find out the potential drop across Rs. We are considering the current passing through this transistor is ID. That means ID current will pass through RD and RS both. So potential drop across RS is ID into RS. So potential drop across RS will come across the source terminal. So Vs equals to ID into Rs. So Vgs equals to Vth minus ID into Rs. By this way, we can find out the gate source potential difference. Now, using this gate source potential difference value, we can easily find out the transconductance using the same equation used previous case. Now, in the third case, further, we are finding out if in the third case the VGS is not given, ID also not given, but threshold voltage of the MOSFET, mobility, Cox and W by L is given. Then we know the gate current is 0, so Vg equals to Vth, and Vth equals to R2 by R1 plus R2 into VDD. So Vgs equals to Vg minus Vs, or Vg equals to Vth and Vs equals to IDRs. So this is my first equation, where Vgs equals to Vth minus ID into Rs. Now in this equation, two unknown parameters are there, Vgs and ID. Now this MOSFET is used to make amplifier. So this MOSFET will work in saturation region, and in saturation region the current passing through MOSFET, we can find out the saturation equation, current equation, and saturation current equation is ID equals to mu Cox by 2 into W by L into VGS minus VT whole square. Also, in this equation, two parameters are unknown, ID and VGS. Now, from this equation 1 and 2, we can find out ID and VGS. So, after finding out VGS, we can use that value in the transconductance equation, and we can find out the transconductance. So by this way, by this DC analysis way, we can find out drain current, VGS, gate to source potential difference, and the transconductance. In the next video, we will do some numericals to find out the GM, transconductance, drain current, and VGS. Thank you.